In this video, I'm going to be walking you through how you can build Conway's Game of Life in React using hooks. So if you haven't heard of what this is, it is a simulation or cellular automation that looks like this, where it's a giant grid with a bunch of cells inside of it, and there's some initial starting state, and then there's some rules at which the cells will either populate or die. And it kind of makes some effects like this, and depending on where you place the cells at the start, you get some different results. So we're going to be showing how you can actually build this. Alright, so let's go ahead and get started. So I ran this command already, npx create react app, and then I called my project Game of Life, and I ran it with the TypeScript flag. You can ignore this if you want to use JavaScript for this. So I ran this already, and so this will create a React project. And what I did is I opened up the app.js or tsx file, and I'm going to start from here. And so I cleared out the extra stuff that was inside of this. And so right now I just have an empty div that says yo, and this is where I'm going to start from. And the first thing that I want to do is I want to create that grid. So to create a grid, in this grid I'm also going to store in state here. So I'm going to say use state, because as we saw, the values are constantly changing. So the grid state is going to be stored in a use state hook. Now I'm going to say grid SetGrid, and here I'm going to initialize the grid. And so I'm going to be using the function. That way this function only runs once whenever it initializes the state. So here I'm going to say const rows is going to be just an empty array. And then what I'm going to do is I'm going to iterate to create rows and columns. So here I'm going to say const num rows is equal to say 50, and num columns is 50 as well. And then we could change these numbers to whatever we like, and we can see that reflected in what it looks like. So what I want to here is just create the rows of our grid. So I'm going to do a for loop to the number of rows, and we're going to say i++. And then inside of here I want to say rows.push. And then here I just want to push a column basically. And so the column is just an array, and how I'm going to represent this is zeros and ones. Zeros means it's dead, 1 means it is alive. And so by default they're all going to be dead, so we're going to put zeros everywhere. So usually when I want to initialize an array with zeros, or really anything, this is how I'll go about doing it. So I'll generate an array, and I'll say the length of the array. So in this case num columns, and then I'll say array.from. And then the second parameter of array.from is a function, and it's a mapping function where you get the value and the key, and then you can return what the value is going to be. In this case, I'd like all the values in this array to be 0, so I'm going to do a function that returns 0 here. And then if I just do a console log of our grid, what should be is a giant array with a bunch of zeros in it. And we just need to make sure at the end of our function here to return rows. Alright, so I'm just going to open up the console, make sure we got this correct by seeing a giant grid. I don't want components, I just want the console. So I have an array of 50, and here we can see a bunch of zeros in there, so perfect. So next up is actually displaying those. So what I'm going to do here is I'm going to say grid.map, and so I'm going to get rid of the console log as well. So now we have rows, so this is going to be an array, so I'm also going to say rows.map, and then so this is going to be a column. And so here I want to just display a div, which is going to be a box. Its width, I'm going to say 20 pixels, and height 20 pixels. And here I'm going to display the background color. And let's drop this to a new line. All I'm going to say for the background color is if it's currently a 1, I want it to be one color. If it's currently dead or 0, I want it to be another color. So what I want to do is I actually need to get the index of things. So here I'm going to get the row index and the column index. Oops. So I'm going to say I for the row index and K for the column index, and I'm going to say grid IK. If it's alive, I want this to be pink. Otherwise, I want it to be undefined, so it's just empty. I'm also going to have a border, which I'm going to say solid 1 pixel black. Alright, and we need to display a key for this because it's an array. Now normally you don't want to use the index as a key, but because we're never going to shift the actual divs themselves, it's totally fine to use this here. So I'm going to say I is the row and K is the column. This will give us a unique key. So we'll give that a save and let's see what this looks like. So now I have a bunch of boxes here. Perfect. And we can easily put this into a grid by using the display grid, CSS grid here. So display grid, and it's template, grid template columns is the property that I'm going to use here. And so here I can say repeat, and then I can specify how many columns I want. In this case, I want num columns. And then the second property is how big I want them to be. In this case, 20 pixels for each one. And I'll give that a save. And there we go. So now we have a giant grid going on here. Perfect. And what I'd like to do is, to get the initial state of our grid, I want to be able to like just click on a cell and make it pink and make that a 1. So to do that, I'm going to make our div clickable. So we're going to say on click, and when it clicks, we basically want to set the current index to a 1. Now we want to mutate our grid now, or at least update the value of our grid at position IK. And it's not a good idea to just update a state value like this to mutate, right? So our grid is in state. We don't want to just set the value like this because this is going to mutate it. So instead of doing this, I want to be able to use a nice API like this, but not mutate the state. And so we're going to install a library to help us out here called immer. So I'm going to say yarn add immer. And immer has a function that we can use called produce. So we'll import that. And so I can say SetGrid, and then I can pass the produce function inside of it. And so and actually, why don't we do this? We'll break it up. So I'm going to say const my new grid is equal to produce. And we pass what our current grid value is, and I'm going to say grid copy. And so we pass our current grid, and this grid copy we can alter in any way we want. So we can say grid copy I k is equal to 1, for example. And that's a totally fine operation. We can mutate it here. But what immer will do is this will make an immutable change and generate a new grid for us. And then here we can say new grid to our set grid. All right, so now can't resolve module. I think I just need to restart. Yeah, I'm just going to Control C and restart my server. So I had yarn start running to start my server for Create React app. Alright, so I said set grid, that'll update the grid with the new grid value that we're creating here. Now I'm setting it to just 1 here. We may want to switch this to be a toggle instead. So let's see, click. Awesome, we can make stuff pink now. So if I click on the pink cell, we can make this toggle back and forth by doing grid at position I, K. If it's currently alive, we're going to make it dead. So now we can flip back and forth. And so now we can set like an initial state for our grid. Now the next thing to do is actually, once we set this initial state, to actually start simulating this. So I'm going to create a button up here, which I'm going to call start. Now what I just did here is I wrapped this in a fragment. And the reason why I wrapped this in a fragment, I could have done a div as well, is you just need to make sure you return 1 value in React, or 1 child. You can't return 2 parallel or 2 children on the same level. So we can wrap it in a fragment like that. So we have our button start here, and I'm actually going to store whether we've started or not in state. So I'm going to say running set running, and by default it is false. So if it's running, we're going to display the value stop for our button, otherwise we're going to say start. In our on click, we can say set running is not running. So we can toggle start and stop now, but that doesn't actually do anything. So let's now actually create a new value for our state based on the current state, or start simulating. So to run this simulation, what I'm actually going to do is I'm going to create a function here called run simulation. And now this is going to be a function. And I'd like this function to not change. So I'm going to be, or at least not be, recreated every render. So to do that in React, I'm going to use the use callback hook. And you'll notice as the second parameter of use callback, I am passing in an empty array. That will make sure that this function is only created once. And you can see this is my function, and then this is the second parameter. So use callback is actually being imported from React. Alright, so in my run simulation, basically what I want to do is I want to simulate, and then I also want to see if we're currently running. If we're currently running, then I would like to, or if we're not currently running, I'd like to return. And then I'd like to actually simulate some stuff, and then at the bottom here, I'm going to set timeout and then run simulation. And then I'm going to set some kind of timeout, for example, 1 second. So this is actually going to be a recursive function, kind of. So when I call run simulation, it's going to make sure that we are running. If we're not, it just returns. So this is our kill condition. Whenever this is false, it's going to die. Then we're going to do some kind of set state logic here, which we're going to add in a second, and we're going to actually simulate the update. And then here we call ourselves again in 100 milliseconds. So it's going to be constantly doing this. So the one problem with also that I'm doing with this is you'll notice that I'm only creating this run simulation function once. But I'm trying to access this running value that's in the state here. And so this is going to cause a problem because the running value changes, but our function does not change. So it's not going to keep up to date with what the value of running is. So in cases like this, what I like to do is I actually like to store it in a ref. So running ref, I'm going to say, and we're going to use the ref hook. So I'm importing use ref there. And then I'm just going to say the running ref is equal to running. And I mean running ref.current. So we're going to say the current value of the ref is whatever the value of running is. And then we can use running ref here. So references, the current value is always going to be up to date in callbacks like this. So whenever you need to use a current value in a callback, this is one way you can do it. Alright, so now let's actually start our simulation bit here. So this is how it works. If we go back to Wikipedia, we can see the rules here. So basically we need to run through the entire grid, and we do this for each one. We check if any cell with fewer than 2 live neighbors dies, any live cell with fewer than 2 live neighbors dies. They also die if they have more than 3 neighbors. If they have 2 or 3 live neighbors, they continue living. And then if a dead cell has 3 live neighbors, it becomes alive. Okay, so let's code that part. So we're going to do 2 for loops. Alright, so this is going to be the number of rows. And the double for loop is just going to go through every cell in the grid. And you'll notice I actually like using k instead of j as my second parameter here. This actually has to do with I use vim and I have it mapped to jk. And so if I use j, it's a little bit laggy. So I end up actually using k for my variable here. But that's just a side note. Alright, so we got my double for loop here, and we're basically going to go through every value in the grid. And so this is another place where we're actually going to like update values in the grid, and we want to just mutate them. So we're going to say const new grid is equal to produce, and here we're going to do this a little bit differently here. So we're going to say than that we did down here. So you see how I said new grid, and I just set the value here in the set grid. That's because we have access to the current grid value. Another way we can do this is SetGrid will give us value. We can actually pass in a function, and the purpose of this function is the parameter here will be the current value of the grid, which I'm going to call G. And then what we're supposed to do here is return a new value for our grid. So instead of returning G here, I can return the produce function, passing in my G. And so here I have my grid copy. And now my grid copy here, I can mutate. So we're going to put our for loops inside of here. So now, for example, I can do any type of mutation on the grid copy, and it's going to update that state for our grid. It's going to set the grid. So now inside of here, what I need to do is I need to compute the number of neighbors that the cell has, and then determine what to do to it. So one way to compute a neighbor, how many neighbors something has, would be to do something like this. So I could say my grid copy here, and I could say at position I, at position k, and we could say k plus 1, and then we could see if it's equal to 1, then we say neighbors, plus equal 1. And then we could do this for k minus 1, and then we could do this for I minus 1, and so on, and basically get the entire grid. So in case you're curious what a neighbor is, it's this grid all around it like that. So this is what we're trying to compute. How many neighbors is the live cells around it. So a trick that I like to do that simplifies this a little bit, and we don't have to write so much duplicate logic, is I'll actually create a array of operations. So for example, I would like to do 0, 1, and then I want to do 0, negative 1, and then I want to do 1, negative 1, I want to do negative 1, 1, and what are the other ones? There's 1, 1, and there's negative 1, negative 1, and then there's 1, 0, and then there is negative 1, 0. Okay, there we go. So this is what, 8? So 4. And this is also 4. Okay, so these are 8 operations. And what that represents, if we hover the neighbors here, is if we think of this as an array, we set the row doesn't change, but we're going to go, the column doesn't change, but the row does. We subtract 1 to go to up a row, and we increase the row value to go down 1. And then each one of these locations is represented by the operation. So what that'll allow me to do is a pretty clean logic here. So I'm going to say for operations dot for each one's going to have an x and a y. We're going to compute a new I, and that's going to be I plus x, and a new k, which is going to be k plus y. And then we're going to say if new I is greater than or equal to 0. So we're going to check the bounds to make sure we don't go around it. And new I is greater than, and not greater, less than the number of rows. And new k is greater than or equal to 0. And new k is less than the number of columns. All right, so this is me checking the bounds to make sure we didn't go below or above what we can. Now here we're just going to say neighbors plus equal our grid. So we could say grid copy, but actually we want to take in the current grid's value, so we're going to actually use G. And we're going to say new I, new k. Right? So if we have a live cell, it's equal to 1, and so it's going to add 1 to the neighbors. So that's going to tell us for a given cell how many neighbors it has. So now we can add an if statement. If neighbors is less than 2, or neighbors is greater than 3, then neighbors, or sorry, not our neighbors, our current grid position dies. So we're going to say grid copy I k is equal to 0. Now, so that covers these two rules. Fewer than 2 dies, more than 3 dies. This one, if they're between 2 and 3, nothing happens. We don't need to do anything. The only other condition we need to do is this one right here. So if the current cell is dead and they have exactly three neighbors, they become alive. So we can say else if the current grid, so that's G, ik is dead, which is equal to 0, and the neighbors is equal to 3, then we can say grid copy ik is equal to 1. Sorry, grid copy. There we go. And that's all the logic that we need in this thing right here. So again, this is the big part that simulates everything. And let's just line break there. All right, so let's just review what we just did here. So it's going to go through the current grid, G, every cell in it. And here we're going to compute the number of neighbors it has. And here we're just going to make sure we check, we don't go out of bounds. So we could go out of bounds for example, this cell right here, because it only has 3 neighbors. So that's the main thing we're checking. And once we compute the number of neighbors, we apply this condition. And this determines whether a cell becomes 0, or if a cell becomes 1, or if nothing happens to a cell. And then us mutating the grid copy here, this produce function is going to generate a new grid for us, and it's going to update the SetGrid value here. Cool. So that is us running the simulation, and then after we update the state, that's going to display something new in the on the website, and then we call set timeout to run it again in 1 second. Okay, so let's just see this in action. If we go to our Wikipedia page, we can actually see some different combinations we can do. So I'm going to do this combination right here. So I'm going to do this one, this one, this one. And so me putting the cells like this should generate that pattern. So I'm going to press start. Oh, you know what? Stop. We forgot to actually call our simulation. So after we say set running right here, we're going to say run simulation. Also, I don't know if we're gonna have a problem with the race condition happening, where we call set running, and this is going to be true. I think what we need to do is we need to say running ref dot current is equal to true. I think we need to update it right here. That way we don't have a race condition between running the simulation and the state update happening. Because when we run simulation, we check at the top of the function if running ref current is false, we return. And it could be false if this state update doesn't happen in time. All right, so that's that. And we only want to run the simulation if we're currently in a starting state, if you will, if it's not running. So if we're not running, this is what we'd like to do. And if we're stopping, yeah, then we don't have to do anything else if we want to stop, I think. Okay, so let's see this. So we click here, click here, click here. And we can press start. And now every second we're going to do a state update. So we can now see that it kind of oscillates between those two values. And that looks to me like it matches what it's supposed to do here. That's pretty sweet. And we can stop our simulation. And we can, add some more cells here. We can run it again, and we can get some new effects happening, and I can stop it. Now what I want to do is just speed this up a bit. And I'm just clicking stuff as this is running, and now it's really going. That's pretty cool. And so there we go. We can watch the simulation. Looks like it's hit like a terminating state here. Can run it, and there we go. So yeah, that's pretty sweet. Now we can definitely add more stuff to this and do all kinds of things. We can play with the time. We can play with the number of rows that we have, number of columns. You can play with the design of what it looks like. So there's a lot of ways you can expand this even further if you like. But this is what I wanted to set up and show you guys and walk you through, was setting up the framework of setting this up. Now, I figured we'd do one last thing, and that's just if we want to add like a button to randomize stuff or to clear stuff. So I'm going to create a button here called clear. And all I'm going to do is generate or basically set the state like this, or reset the state, if you will. So actually, why don't I create a function here called generate empty grid. And I'm just going to copy our set state logic here, and we're going to return generate empty grid. So then we can use that in our clear. I can say SetGrid is generate empty grid. And then I can also create a random, and this is where we can just set the grid up with randomly alive and dead things. And this might just be fun to generate cool simulations. So I'm going to copy this again. And this is our random. So here for the rows, we're going to say SetGrid. We're going to pass in our rows. So now instead of just passing 0 for all of them, we're going to say math.random. If it's greater than 0.5, it gets a 1. Otherwise, it's a 0. All right, so let's take a look at this. So now if I press this, cool, there's just a random collection of pink stuff on the screen. If I press random a couple times, it should do that. And it's going to distribute it roughly half and half. We can play with the probability if we want to and get some different results. But let's go ahead and run this now and see what the heck happens. Wow, everything just like insta-died. I think it's because they were too close. So I'm actually going to go up so it's a little sparser. Start this. All right, this is a better sparsity, I think. And we can just let it run and see what happens. We can let this run. I'm not sure if there's like a way to know if it's going to go into an infinite state or eventually whittle out, but we can stop it, we can clear it, we can generate another state, we can click in stuff we want to. But there you go. That is Conway's Game of Life built in React and using hooks.